Okay, so now we're going to talk about the MTL, which is the medial temporal lobe. And you can think about this because this is like the middle time lobe. And so in the middle of time, so just think about your brain, and it's there's a clock right in the middle. So medial temporal lobe is the MTL. Okay, and so the MTL can receive input from association cortexes. And what are these association cortexes? They can be frontal, parietal, temporal, and angulate. And think about this as front parrot time angle. And so that's like the angle that a parrot can turn, and what time that angle is. It's that he can turn his front from like one angle to another angle. And so like how much time does it take for a parrot to rotate? Frontal parrot time angle. Yeah. Frontal, parietal, temporal, angulate are the input areas. Okay, and so now this input goes into the parahippocampal cortex, and then the association areas. And so once they go into the parahippocampal cortex, then they go through the medial and entorhinal cortex via the hippo, or they. Okay, so basically, just to break it down, what you're trying to get into is you're trying to go from the association areas into the hippocampus. And so basically like input that you're getting to the hippocampus, which is a spatial more type thing. So you're trying to take association areas and put them in a spatial context. Okay, and so the way that you can do this is you take input from the association areas and you go into the parahippocampal cortex, and then you go through the medial and entorhinal cortex. And when I mean through, I mean like it's like a tube, like you're going via that. And so just think about this as association areas, parahippo, and then rhino. And so, like ass, hippo, rhino, because association cortex is ass, parahippocampal cortex, hippo, parahippo, and medial entorhinal cortex, which is the tube that you go through, is the medial entorhinal cortex, and then you end up at the hippocampus at the end of the medial entorhinal cortex. Okay. And so basically all of this is just we want to get from the association areas into the hippocampus. And in order to do that, we need to go through parahippocampal cortex, the medial entorhinal cortex, and then that gets us to the hippocampus. And so just think about go from association areas, hop right on over to the parahippocampal cortex. And so like if you want to associate with the hippo's girlfriend, so association cortexes, parahippocampal cortexes, you have to meet the rhino, medial entorhinal cortex. And then that leads to the hippocampus. Okay, so just one more time because pathways are hard. You want to get from the association areas into the hippocampus. And so basically what you want to do is you're trying to get from like an associated like kind of acquaintance all the way into meeting the hippo, like being tight with the hippo. And so the first stop is going into the parahippocampal cortex, which is like his girlfriend. And then the tube that you go through to get to the hippocampus that his parahippo or his girlfriend sends you through is the medial entorhinal cortex. And so you can think of this as like you're riding a rhino from his parahippo girlfriend. And then you ride a rhino all the way to the king hippo. And then you're there. It's great. Okay, and so then what do you do when you're at the hippocampus? You go through the fornix and mammillary bodies. So fornix and mammal bodies. Yeah, we'll just say that. Fornix and mammal bodies. And then you end up in the anterior thalamus, which is the front of the thalamus. And then you finally go to cortical regions. And then that's where you kind of like process things. You know what the cortex does. Okay, so just to review, you want to be associated with this hippo. Okay, and so you want to be associated, you're like an acquaintance, and so you go meet his parahippocampal girlfriend, and this is the parahippocampal cortex, and then she sends you on this rhino, which is an entorhinal cortex, and then that gets you to the hippocampus, and then the hippocampus introduces you to his mammalian friends, which are the mammillary bodies, and also the fornix, and you can think of the fornix as like his little horn, because rhinos have horns. And then you get to the anterior thalamus with all his mammal friends. So that's the front of the thalamus because all his mammal friends and the fornix help him skip to the front of the line, like the fornix on the rhino and like all his mammal friends. That's going to help you get to the front of the line in the thalamus. Okay, and then thalamus, just think of thalamus as like this hip new club that you want to go to with like this hippo. Okay, and then finally, once you get inside the club, that's like the cortical region, and so that's where you do your processing. So just to go over this one more time, because literally processing and pathways are pretty hard. You want to get to know this hippo, so you start in the association areas. You go through the parahippocampal cortices, his girlfriend. You ride a rhino, entorhinal cortex, to the hippocampus, who's like the boss hippo. He introduces you to his friends, the mammals, mammillary bodies, and then the rhino comes along with you, and the rhino's little nose thing is kind of like a fornix, and then you get to this hip new club, which is the thalamus, and you get to skip to the front of the line, the anterior thalamus, because you have all these mammillary bodies and the fornix that just lead you right to the front of that line. The mammillary bodies and the fornix lead you right to the front of the thalamus, so that's the anterior thalamus. And then once you get inside of this club, that's where you can start processing things in the cortical regions. Okay, and so that was pretty long-winded, but essentially, that's done with for now. Okay, and so now moving on to special patient cases. Okay. The first special patient case is HM, and HM is probably the most well-known one. Let's just checking how much more we have left. Okay, and so HM was in 1953, and HM had a bilateral temporal lobectomy. And so what that means is both sides and then temporal, so both sides of his temporal region were cut out. And so lobectomy, bilateral temporal lobectomy. And so you can think of this as BTL, which is bring the limes. And bring the limes is something a crazy person would say, like a crazy disoriented person. And HM was like kind of disoriented because he didn't have his memory. And so bring the limes is something similar that HM might say. Okay, and then you can think of HM because he got rid of the temporal region, and so that's a time-sounding area of the brain. And then this is a bilateral temporal lobectomy. You can think of this because it's like HM, which is hit me on both sides at the same time. And so HM hit me on both sides at the same time because it was his temporal lobe that got taken out, and both sides at the same time because it was a bilateral lobectomy, meaning that both sides of his temporal lobe got taken out at the same time. Okay, and he did this to cure epilepsy. And so what were his impairments because of this? Well, first off, HM was bad at forming new declarative memories. And so declarative memories are things that you can kind of like say, like, declarative memories are things that you can say. And if you don't have declarative memories, that means you have anterograde amnesia. And you can think of this because anterograde sounds like ant. And ants don't have the ability to declare stuff. And so anterograde amnesia means you can't form new declarative memories. And so ants cannot form new declarative statements. And so anterograde amnesia, you cannot form new declarative memories. And so that's how to remember that. Okay. And so, and then another way to remember it is that the root, which is the front, means anterograde, so that's like front grade. And basically what you need to know is you can't form new memories, so you can't form new episodes in front of you. So anterograde amnesia means that you can't form new episodes in front of you, and episodes are a form of declarative memories because declarative memories you can like say and you can verbalize something that is an episode. Okay, and so who studied him? Who studied him was Brenda Milner and Sue Corkin, and you can think of this because HM, which is hit me on both sides, had had anterograde amnesia, and you can think of an ant farm with a mill in it for milliner, and like someone's like milling this ant farm because it's a mill. And then you can think of Sue Corkin because there's a cork in the ant farm. Like you keep the ants in the ant farm with a cork in the top. And so that's an easy way to remember. Brenda Milner and Sue Corkin studied HM. And another thing to know about HM is that he was intellectually intact. And so that means that he had normal working memory for at least a little bit. And but he had bad long-term for declarative. Okay, and another thing to know is that he can acquire new skills. So, like with the mirror test that everybody knows, that's one of the most famous ones. And also, probably another important thing to note was that he could acquire knowledge of people with conditioning. And so if he kept seeing someone, maybe, this is what I'm just saying, if he kept seeing someone and he was conditioned to know that they were mean, maybe if he met them again, I mean, if he wouldn't be meeting them for the first time, but if he thought that he met them for the first time, he'd immediately get like a bad feeling because he was conditioned to not like this person. Okay, and so HM can't remember his past, because he doesn't have declarative memory, and he can't form new future memories, and thus he can't remember his past, and he can't remember, but what can he do? He can remember skills like the mirror test, and he can remember implicit knowledge, like where's the bathroom or something. And so there's that. He can't remember who his wife is, but when he meets her, he knows some details of her, and she can teach him skills, plus some knowledge of who she is, like some working knowledge that he'll remember for a little bit. And so basically, he doesn't remember his past, he can't form new declarative memories, but he can learn skills. And this is because of a bilateral temporal lobectomy, because it's both sides of the time-sounding portion, you just take them out. Okay, and then bilateral temporal lobectomy is BTL, which is like bring the lines, and that's the way to remember it. Okay, and so MTL is for decoding. Okay, so basically we're saying, like, why did he have these deficits? Like, what was wrong with HM? Like, what did you take out? And what you lesioned was the MTL. And so what to know about the MTL is that it's for coding declarative memories. You need to remember this because MTL in reverse is long-term memory. And long-term memory can sometimes consist of episodes. Like, if you think of long-term memory, you're probably thinking not about, like, oh, random facts, you're probably thinking about, like, the history of you, like, what your experiences are, what you've learned, what you have gone through, the people you've met. And so MTL backwards is LTM. And the LTM is not crucial for working memory. And so working memory is somewhere else. But the MTL is going to encode things further into the brain, and so you do need it for that. But MTL is not crucial for working memory or non-declarative memory. And so non-declarative memory would be like certain facts. And so going back to how HM can remember conditioning of people. Okay, and so just to review, the MTL is for declarative memories, which are like episodic, the history of you, and you can remember that because in reverse, MTL is LTM, which is long-term memory, and you can think about the story of you, and the MTL is not crucial for working memory. Again, HM could be conditioned, and it's also not important for non-declarative memory because of like this conditioning again. Okay, and so now we're going to get into different types of memories. Okay, and so within memory, there's two types. So there's working and long-term, and the working, things that you learn in the working, are sometimes going to be transferred over to the long-term. Okay, and so within long-term, there are declarative memories and non-declarative memories. And so declarative memories are explicit. And you think about this as like declaring a swear word. Like declarative memories are explicit. Like you can say them. And so as far as like things that you can say, declarative, explicit memories, these include episodic events or semantic information, which is facts. And so just to go through, a category of long-term memory is declarative, which is like declaring swear words. It's something that you can say. And so within declarative, there are episodes, which are episodic information, which are events, and also semantic information, which is just facts. Okay, and so going over to non-declarative, which is implicit memory. Implicit memory is not something that you can say, it's just something that kind of is. Okay, and so this includes, this could include skills, priming, and conditioning. And so think about this as SPC. Okay, so non-declarative, which are implicit memories, it's like not something you can verbalize. So skills, you're going to probably have a hard time explaining how you do some skill. Like an X-ray tech would probably have a hard time explaining how to read an X-ray. And another one is priming. Priming is unconscious, so that's by definition an implicit memory because you can't talk about it or declare because you don't know. And conditioning, you don't have to talk about that. Just think about the mice fear conditioning and like these shocks boxes. Like that's not a declarative memory. Like you can't talk about that. Conditioning is just like kind of intuitively building in a response. And so once again, non-declarative memories are skills, priming, and conditioning, and declarative memories are episodic and semantic. And I think the key thing here to remember is that semantic memories are declarative. Semantic is declarative. Semantic is declarative. You can think of this as Samantha Orr. After high school, Samantha Orr got pretty declarative and pretty bold and out there. Okay, so semantic memories are declarative, which means explicit, which means you can talk about them. Okay, and then the final little tiny tidbit to know is that you encode different types of memory by the quality of these memories and the duration of these memories. Okay, so quality, duration, like how good is it? How long does it last? It's kind of like sex, huh? Quality and duration. Okay,